Hello everyone, today I will be talking about function point estimations. Let's quickly get started with an introduction. Firstly, today's software applications are very heterogeneous in nature. They use different technologies, tools and several programming languages. Even software components are readily available from different vendors. Therefore, the software system continues to grow in size and complexity. They are very difficult to understand and assess. Therefore, it is impossible to manage what we do not understand, and we cannot understand what we cannot measure. Therefore, the size of the application really matters. So in this video, I will be providing an insight into function point estimation and its benefit in software sizing along with a case study. Function point estimation is a ISO standard estimation technique which uses function point complexity combined with best practices or historical standard metrics to derive the efforts. It is used for development projects, enhancement projects, or even a maintenance project. So we are going to work with a case study for a development project. There are currently 5 variants of function point estimation, and we are going to talk about IFPUG function point estimation. IFPUG means International Function Point User Group. Now let's look at some of the advantages of function point estimations. It is independent of computer language, development methodology, technology, platform, or the capability of the project team. It is linked directly to the user requirements and functionality, which helps us to easily compare estimates with requirements, such as bidirectional metrics, for example. It is applicable from the earliest requirement stage and throughout the software development lifecycle. Function points can help establish effective communication between the end users and the software developers. Since function points are based on users using the system, even non-technical users of the software applications can get a better understanding of what function points are. Let's look at some key terminologies. From the end user point of view, we look at the software application as a combination of data at rest and data in motion. Data at rest represents data storage in the form of files called data functions. Data in motion represents some activity that the end user is carrying out while processing the information, called data transactions. So that gives us two major categorization. One is data functions and the other one is transaction functions. Data functions is having two subcategories, that is internal logical file and external interface files. Internal logical files are basically the information that we save inside the application, and the external interface files are the data that resides outside of our application boundary. Transaction function has three categorization. The first one is external input. That is the data that is coming from outside the system. It might not be only the data, it can also include commands. External output, the data or commands that is going to the outside of the application. External inquiry is the request response type of activity. This is a typical representation that we can look at. Here we are having an end user who is making an input, output and inquiry transactions, and we are having an external system over here which is basically carrying out three different operations. And internal logical file is our internal data. In addition to this, we need to understand these three elements, that is DETs, RETs and FTR. The data element type DET is unique user recognizable, non-repeated field or an attribute of a ILF or a EF. I can say that it's a column in a table. A record element type, also known as RET, is a user recognizable subgroup of a data element within an ILF or EAF. I can say it as a table. When ILF or EAF are referred by transactional functions for processing the information, then we call them as FTR or file type reference. Let's start with the case study. The problem statement that I have put together is building a real-time member eligibility application project, and the effort needs to be shared to the customers and provide justification on the final effort. Member eligibility application I can say that when you go to the hospital, you want to know the eligibility of your medical coverage by insurance company. So the hospital staff basically submits a request. The request goes to the insurance company, and you get a response back stating whether you are eligible for a coverage or not. Very simple. So the solution that I'm going to use here, that is sizing the requirement, is function point estimation. So here I put together a flow diagram in which it shows a user who's a doctor or a hospital staff submits a request for eligibility. Request goes to the transaction API, hits the database, and then the response is sent back. In addition, the user is also having a web portal using which they can modify the member data if there is any correction. And also we have a feed file which gets the member information from an external source. Splitting the requirement, this is an optional step for us to get a better understanding of the requirement. Here the user is trying to query the transactions, and the user here is trying to update the member data. Let's try to understand the input and output details of various transactions. The transaction API sends a request, and it has member first name, last name, date of birth, member ID, insurance ID to search for a member eligibility information, and the response contains the member information, insurance, procedure details, and diagnosis details. Then the web portal is basically used to make corrections to the member information, and the feed file contains the member data that is loaded to the database, and it has this set of data. So with this information, let's go to the next slide and see. So complexity chart, we need to understand about the complexity chart. First is for internal logical file, we have for the given RET and DET, what is the complexity level, and for that complexity level, what is the function point. In a similar manner, we are having for external interface files, external inputs, external output, and external inquiries. These are some of the formulas that I will be using. That is, unadjusted function point is equal to data functions plus transaction function. The value adjustment factor is equal to TDI into this, and adjusted function point is equal to unadjusted function point into value adjustment factor. Let's work through the interpretation. This is the system under study, and these are the various tables that we have, and these are called internal logical files. Next, we have a user, and we have a feed file which gets a batch update of member information. So the batch file contains all this member information, and this is called as an external interface file because the data comes from external to the system. Transaction that is coming outside is called as external input, EI. Then let's see what are the transactions that the user makes. So he is able to do a search operation using these fields, and that is called as an external inquiry, EQ, because it is bidirectional in nature. Updating the member, it is unidirectional, and it is called as external input. It is coming from the user to the system. Someone might even ask us, an update, I get a status back. So those getting the status true or false is not considered as a EQ type of transaction. Majority update operations are considered as EI operations. Similarly, we are having add, update, and delete procedures, and diagnosis code, and insurance code. And there is one more transaction which is sending out a weekly transaction statistics, and this is considered as an external output because it is coming out of the system. There could be more of such transaction, but I would like to limit for this transaction for the sake of simplicity. Let's go to the identification phase. This is the important phase in the function point estimation. Let's try to identify the data functions. So data functions are of two types, that is internal logical file and external interface files. So in internal logical file, so what are the files that we have? So we have a member table. So for the member table, we need to identify what is the DET and RET associated with it. So let's open up the chart and see here for the member table how many fields, unique fields are there. So 1, 2, 3, 4, 5, 6, 7. So we are having 7. So 7 is the DET. And what is the record element type? It is one table. So we are having 1. So what is the weight associated with for the DET and RET? So we need to use the complexity chart. That is this. So for internal logical file, for a given DET of 7 which falls between 1 and 19, and RET of 1, the complexity is low. And if you go into the complexity chart, we are having low as 7. So low and function point is 7. So we are going to do the same exercise throughout. These are the DETs and associated RETs. The same thing we can do it for external interface files. The only difference is we need to use the external interface chart for this one. For external interface files, we are getting 11 fields from the external system, which is having 3 RETs. Like we are having member address, and one more table. So it is associated with 3 tables. And then the weight that we are getting is L. If you see here in the chart, between 1 and 19, 11 and 3. So 3 is between 2 and 5. So it is a low, and then we are getting 5 points for it. So with that, we need to calculate the data unadjusted function point, which is 47. Let's go ahead and do this same for transaction function. In this case, we are going to have 3 transaction types: EI, EO, EQ. So EI, so what are the various transactions we saw? One is updating the member. So let's look at the chart. When we update a member, how many fields are getting affected and how many tables are getting affected? That's what we have to see. If you take member, we are having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? So 11 fields are getting affected by updating the member. It could be more, but for the sake of simplicity, I just consider these 2 tables as getting affected. So with that, we get 12. The reason is when we use an update, we need 1 point for the update button click event. Alright. Also, if there is any computation that is happening, we can add 1 point for one complex computation. So let's look at the FTR. FTR is 6. That is, it is affecting all the tables. So with that, let's look at the next chart of identifying the function point. It is similar to what we did for the internal logical files or external interface files. 12, 6. So if you go into the external input table, 12 comes under DET 515 and 6 is here. So it is a high. For high, the function point is 6. So in the similar manner, we have to do for all the other transaction functions. Add procedure 6.1 L. So add procedure is a EI function. 6 and 1 is a low. Low is a 3. So I have identified all the transactions that is happening, and the same process I am going to follow to identify the function point. The same thing we have to do it for EQ and EO. So finally, we have to come up with the total transaction function points, that is unadjusted. So the reason that I am saying is unadjusted is because it is having some non-functional requirements that has to be added, which I will be showcasing in the next slides. General system characteristics. There are 14 general system characteristics that the ISO has come up with, which we need to scale on a rate of 0 to 5. Let's say data communication. Data communication, yes, we need to take care of it. And what is its degree of influence? It's 3. Maybe it might be a 5 based on the requirement. Distributed data processing. Maybe we might have some load balancing happening, or we might need to deploy it in different areas and reduce the latency. So all this is going to add the complexity level, and then we are going to determine what is the degree of influence. So for the sake of this exercise, I have given 3 for data processing. Similarly, we have to determine the requirement. If you do not have such requirement, you can mark that as 0. And finally, we need to come up with the total degree of influence, or TDI. Let's go to the final calculation. So total unadjusted function point is equal to data function plus transaction function, which is equal to 47 plus 46, and that is equal to 93. The next thing we have to determine is a value adjustment factor, which is given by this formula, and we know what is the TDI value. It's a 38. So when you calculate, you are going to get 1.03. So finally, we have to determine what is the adjusted function point. That is equal to unadjusted function point into value adjustment factor. That is equal to 95.79 is the adjusted function point. The next thing that we have to do is to determine the effort that is required to complete this particular application or project. So for this is the formula that's been used, and here PF, is the productivity factor. So here I've taken a standard 18 function points per month, but it depends on individual organization based on past experience. Okay, if you do not have one, you can take 18 as a standard function point per month. Then 20 is the ideal working days. I have not included any holidays in this, and 8 is the ideal working day I have taken. So using this, if you calculate, we are going to get 844. 844 hours that is required to complete this particular application. So this is how we carry out a function point estimation. Let's look at some of the disadvantages of function point estimation. It's time consuming process. The learning curve is big. We need to understand a lot of different parameters to effectively estimate a function point. Then the lack of requirement might result in a poor estimate, because we need to understand all the various functions that are interacting with the system to get a more accurate estimate. The function point estimation needs subjective evaluation, which has a lot of judgments involved. Then finally, it is absolute in nature, and it might result in unhealthy team competition whenever the estimation is not agreed by one team or the other. Thank you for watching, and see you in the next video.